Hi everyone. In this video, we're going to be doing A-level Maths 9709, paper 45, Mechanics, May, June 2025. This paper is 1 hour 15 minutes long, so we'll try to finish within that time limit. So without further ado, let's get started. Okay. Sorry. Okay, so for the first question, we're told that a box of mass 25 kg is pulled 12 meters up a rough plane, inclined at an angle of 8 degrees to the horizontal. The box moves up a line of greatest slope against a frictional force of 50 newtons. The force pulling the block is parallel to the line of greatest slope. The box starts from rest and has speed 2.4 at the end of the 12 meters. So using all this, we have to find the work done by the pulling force. Okay, so first of all, let's sketch a diagram of whatever they describe to us in here. Yeah, so this is at an angle 8 degrees, and this is 25 kg, and then it's pulled by okay, so the force of pulling it up is 15 newtons. Okay, and okay, what else do we have? Oh, that it moved 12 meters. Okay. All right. Anything else? Okay, so from here it started at rest. Okay. And then all the way here, it's going at 2.4 meters per second. Okay, I think, yeah, that's all the information we have. So to do this question, we're gonna have to use an energy method. Okay, so okay, first of all, let's oh wait, sorry. This is the frictional force, 50 newtons, and this is the pulling force T that we have to find. Okay, actually we don't have to find the pulling force. Okay, so yeah, so let's use the yeah. So let's calculate the initial energy. Okay, so initially, so initially we initially there is no GPE, no KE, nothing. So yeah, so we're just gonna take it as 0 joules at the start. Okay, and finally we got KE at the end, which is half mv squared. So half 25 kg and v squared, 2.4 meters per second squared. Yeah, so that's that. Sorry, let me see where my calculator is. Okay, so half times 25 times 2.4 seconds squared, you'll get 72 joules. And then GPE has also increased, okay, mgh. So m is just 25, g is 10, and h is the vertical height that the block moved through. So that's just 12 sine 8 degrees. So I recommend you to leave it in exact form. So this is 3,000 sine 8 degrees. Okay. And now we're going to have the work done against frictional force. So that's just FD, where F is the frictional force, 50 meters, 50 newtons, and distance is 12. So this is just 600 joules. Okay. Okay, so initially we must have for an energy. So that energy would be work done by pulling force. So we're just going to equate these two. Hence, work done by force would just be the sum of all these forces that we computed. So 72 joules plus 600 joules plus 3,000 sine 8 degrees joules. This would all be equal to 1,000 1,090 joules to 3 SF. So this is our final answer for the first question. Let's head on to the second question. So for this question, we're told that a machine for driving a nail into a block of wood causes a hammerhead to drop vertically on top of the nail. The mass of the hammerhead is 1.5 kg. Mass of the nail is 0.005 kg. See the diagram for that. The hammerhead hits the nail with speed 32 meters per second and remains in contact with the nail after the impact. So that means basically they coalesce, they become one body. Okay, so for the first part, we have to calculate the speed with which the combined hammerhead and nail move immediately after the impact. Give your answer correct to 3 decimal places. Okay, so for this, we would have to use our conservation of momentum formula. So to do that, let's calculate the initial momentum for the hammerhead and the nail. So hammerhead is just P equals to mv. So m is 1.5 and speed is 32 meters. As for the nail, since it didn't move at all initially, there's no momentum in it. So it's just a 0 Newton second. So initial momentum for hammerhead is just 48 Newton second. Okay, now we're going to equate this 48 Newton second with our new momentum after the impact. So the new momentum, both the nail and hammerhead, they remain in contact. So we're just going to take them as one body now. So this is their new mass and new speed. We're going to let it be V. So now we're going to solve for V. So V is just 48 divided by 1.5 plus 0.005, which is 1.505. And this is equal to 31.894 meters per second to 3 SF. I mean, 3 decimal places, sorry. Yeah, so this is our final answer for the first part. Let's head on to the second part. Okay, so for the second part, we're told that there's a constant force resisting the motion of magnitude 25 newtons. So yeah, so basically, like when the nail is going down, there's a force that's acting upwards on the nail that's resisting its motion of 25,000 newtons. So using this, we have to calculate the distance the nail is driven into the wood. Okay, so to do this, um, okay, 40. Okay, so the resistive force is 25,000 newtons. Okay, and all right. Okay, so we're going to, okay, so let's calculate the force that the nail delivered. Yeah, so it is, they did not give us the time. Yeah, so this is just gonna a square 2as. Okay, I think we should find the the deceleration. Okay, so so the weight would be the force as well as the nail's weight. So this would be the force that's driving it down. So we're going to use F equals to ma. Okay, and going to take 1.5 g plus 0.005 g minus 25,000 newtons equals to ma. So m is basically the nail and the hammerhead. So 1.5 plus 0.005 A. Okay, so hence A would just be 1.5 times 10 plus 0.005 times 10 minus 25,000 newtons. This would be minus 2498.95 divided by 1.5 plus 0.005. This is 1.505. Hence, this is 24,984.95 divided by 1.505. Okay, deceleration would be 16,601.296 meters per second squared. Okay, and now we're going to use our Suvat equation. So this equation from your MF19 and the mechanics. Yeah, so we're going to use this one. V squared equals to U squared plus 2as. So let's write it down. So U squared is obviously our initial speed. So that's 31.894 square plus 9 times 16,601.296 S equals to 0 square. So just make S the subject. So minus 6.01.296 times 2, you will get 33,202.592 S equals to minus 1,017 227, and just divide both sides by the left hand side. You will get 0.0306 meters to 3SF. So this is our final answer for this final part, as well as the entire question. Let's head on to the next question. Okay, so for this question, we're told that a train travels 4.8 kilometers between two stations A and B. The train starts from rest at A and accelerates at a constant rate until it reaches a speed of 30 meters. It then travels at this constant speed for t seconds before decelerating at a constant rate, coming to rest at B. Total time for this journey is 180 seconds. Okay, so using all this, you have to find the value of t and hence find the distance moved by the train while traveling at a constant speed of 30 meters per second. Okay, so to do this question, we're going to sketch a velocity time graph in here. So this would be y-axis would be our velocity axis, and x-axis would represent the time. Okay, so at time t0, it starts from rest at A and accelerates at a constant rate. So if it accelerates at a constant rate, we're just going to draw a straight line, since the gradient of the velocity time graph represents the acceleration. So since the acceleration is constant, the gradient will be constant too. So this would be 30 meters per second. And then it travels at this constant speed for t seconds. So we're going to let this be t. Okay, they did not say what the time here is. And then after t seconds, it starts to decelerate at a constant rate. So again, this would be a negative gradient, constant negative gradient coming to rest at B. Okay, and this train reaches B at 180 seconds. Okay. Yep, that's all. All right. Yes, yep, I think, yeah, this is all the information that we have. All right. So now we're going to make use of this information, the distance between the two stations, 4.8 kilometers. So you have to know the area under the graph, under the velocity time graph, always represents the distance traveled. So this is 4.8 kilometers. And since our speed is in meters per second, we should change it to meters. You can do it by adding 1,000. So this would give you 4,800 meters. Okay, so now we're just going to find the area of the whole graph and equate it to this. So this is a trapezium, so it's half times the sum of the parallel sides. So we don't know this. We'll let this be x, okay? So this x plus the other one, it's just 180 times the height, which is 30, equals to 4,800 meters. and then x plus 180. This is just going to be 4,800 divided by 15, which is 320. And then x, you would get 320 minus 180, which is 140. So this interval is 140 seconds. Okay, sorry everyone. Just realized what my mistake was. Okay, so t seconds is the time that the train was traveling at a constant speed for. So this is not going to be t. Let's say this is y, so this is going to be y plus t. So that's basically our x. So x is 140, so we can say t is equal to 140 seconds. And now we have to find the distance moved by the train. So for this, you can just take the area under this rectangle. Okay, so you know the width, that's 140, and the height, that's 30. So in total, this would just be 4,200 meters. So this is our final answer for this question. Let's head on to the next question. Okay, so for this question, we're told that coplanar forces of 17 newtons, 51 newtons, and 34 newtons act at a point along the direction shown in the diagram where tangent alpha is equals to 15/8. So for this question, we have to find the magnitude and the direction of the resultant of the three forces. Okay, so to do this question, let's take the vertical and horizontal component of each of the forces. So let's start by taking the horizontal component. So for the 34 Newton force, we have 34 cosine alpha. And then for the 51 Newton force, we have 51 cosine alpha. And then 17 newtons. This would just be 90 minus alpha. So this is 17 cosine 90 degrees minus alpha. Okay, so 90 minus alpha cosine, it is the same as just 17 sine alpha. Okay, so let's draw a triangle for alpha. So we know tangent alpha is 15/8, so 15 would be the opposite and 8 would be the adjacent side. So using Pythagoras, we can find the hypotenuse, which is 17. Hence, sine alpha is 15/17, and cosine alpha is 8/17. So, yeah, so let's take this as the bigger one. So 34 cosine alpha plus 51 cosine alpha minus 17 sine alpha. So 34 plus 51, that is 85 cosine alpha. Cosine alpha is 8/17 minus 17 sine alpha, that is 15/17. So putting all this together, you would get 40 minus 15, 25 newtons horizontally. So since we took this as the bigger one and we got a positive answer, the resultant force would be acting in this direction. So we'll call this Fx. Okay. So that's the horizontal component of the resultant force. Okay, now let's find the vertical component. So for the vertical component, we have, for upwards, we have 51 sine alpha, and downwards, we have 34 sine alpha plus 17 sine 90 minus alpha, which is the same as sine cosine alpha. So, okay, we're gonna take 34 sine alpha to be bigger. So 34 sine alpha, that is 15 over 17 plus 17 cosine alpha, that's 8 over 17 minus 51 sine alpha. So 51 times 15 over 17. This would give us it's 15 with 51 times 15 over 17 of minus 7 newtons. So if we get a minus, that means like it's not going to be acting in the first force that we took. Like, so we assumed that this one was bigger, but it's not. So we got a negative answer. Hence, the resultant force, the vertical component, will be acting here. So this is Fy. Hence, Fy is equal to 7 newtons. Okay, now let's see if there's anything else. Nope. Okay. Right, so we found our Fx and Fy. Now we can find the magnitude by using Pythagoras theorem. So F would just be 25 square plus 7 square rooted. So this will give us square root 674 newtons. Okay, now we're going to find the direction. To find the direction, we are going to have to find the angle of the resultant force F between the horizontal. So we're going to call it beta. And to find it, you just take tangent beta equals to Fy over Fx. So that would just give you 7 over 25. And you just take the inverse tangent, you will get tangent inverse 7 over 25. You will get 15.6 degrees to 1 decimal place. Okay, so yeah, so we can say that Fx 25 degrees above the horizontal. Okay, along the horizontal OX. Yeah, so this is the direction. This is how you express the direction of force, and our magnitude is squared 674 newtons. Yeah, so this is our final answer for this first part. Let's head on to the next part. Okay, so for this second part, we're told that the force of magnitude 51 newtons is replaced by a force of magnitude Pn acting in the same direction. The resultant of the three forces now acts in the positive x direction. So for this, using this, you have to find the value of P. Okay, so I'm going to erase all this so that we can start fresh. So we're told that instead of this 51 newtons, this is just P newtons. And now the resultant force only acts in this direction. So F is just here. So if the resultant force only acts in one direction. In the horizontal direction, it means our vertical forces, they're still in equilibrium. So let's take our vertical components. So upwards we have P sine alpha, okay? And then downwards we have 34 sine alpha plus 17 sine 90 minus alpha, which is the same as 17 cosine alpha. Yeah, so we'll just equate both of these. Okay, so there's our vertical forces. We'll write 34 sine alpha plus 17 cosine alpha equals to P sine alpha. All right, now we're just going to solve for P. So sine alpha, referring back to a triangle, it's 15 over 17. So cosine alpha should be 8 over 17. And P is sine alpha. Sine alpha is 15 over 17. So 15 over 17 P is equals to 34, 15 over 17 plus 17 times 8 over 17. This is 38. And then dividing both sides by 15 over 17, you will get 646 over 15. Or you can just leave it like this. This is our final answer for this second part, as well as the entire question. Let's head on to the next question. Okay, so for this fifth question, we're told that a car of mass 1500 kg is traveling along a straight horizontal road. For the first part, we're told given that there's a constant resistance to motion. Engine of the car is working at 24 kilowatts while the car is traveling at a constant speed of 32 meters per second. Power is now increased to 28 kilowatts. Okay, and then for using this, we have to find the acceleration of the car at the instant it is traveling at the speed of 36 meters per second. All right, so to do this, we're first going to find the resistive force. So to do that, we should know that when the car is traveling at this constant speed, both the driving force and the resistive force are in equilibrium, so they're both equal to each other. So to find that, we just have to find the force exerted by the car while it was working at 24 kilowatts and traveling at 32 meters per second. So we're going to use P equals to FV. So FR, that's our resistive force, is just P over V. So P is just 24 kilowatts, so that's 24 times 1000 over V, which is 32 meters per second. So this gives us 750 newtons as a resistive force. Now we have to find the new driving force when it is increased to 28 kilowatts. So to do that, we should also know the speed at which it's traveling. So in this case, we're told to find it at the instant it's traveling at this speed. So again, we're going to find our driving force using the same formula. So this is going to be 28,000 over 36. That is going to be equal to 7,000 over 9 newtons. And I always like to keep mine in exact form, so that you don't get any rounding errors in your final answer. So now we're going to use F equals to MA, our second law, and we're going to subtract FD from FR. So 7,000 over 9 minus 750 is equals to m, which is 1500, times a. So a would just be 1 over 1500 times 250 over 9. So this give us 1 over 54 meters per second square. So this is our final answer. This is the acceleration at the instant. So with that, let's head on to the next part. Okay, so for the second part, we're told that it's given instead that the resistance to motion of the car is this much. So it's a function in terms of v, while the speed of the car is v meters per second. And we're also told that when the car engine is working at 20 kilowatts, the car is traveling at a constant speed. And we have to find this constant speed. All right, so again, when the car is traveling at the constant speed, it means that the force exerted by the engine is equal to the resistance of the motion. So we're going to use, again, E equals to FV first, and we're going to find FR. So that's just P over V. So P is just 20,000, and then V, that's just V. And now we're going to equate this 20,000 over V to the resistance. That's just 340 plus 4V. Okay, now we can multiply both sides by V. So we get 20,000 equals to 340 plus 340. Sorry, let me erase this. 340V plus 4V squared. So 4V squared plus 340V minus 20,000. That's equals to 0. And now we're going to divide all the coefficients by 4. So V squared plus 85V minus 5,000 is equals to 0. So now we have a quadratic equation to solve, and we're going to try factorizing it, or you could use a quadratic formula, up to you. So let me try factorizing this. Okay, so I got V minus 40 and V plus 125 equals to 0. So we're going to equate each of these factors to 0. So first answer we got V equals to 40. And the second answer would just be V plus 125 equals to 0. We get V equals to negative 125. And since V cannot be negative, we're going to reject this. Hence, this is our final answer, and we can write speed as 40 meters per second. So this is our final answer for this second part, as well as the entire question. Let's head on to next question. Right, so for this question, we're told that a particle P moves in a straight line starting from a point O. At time t seconds after leaving O, the velocity v meters, so P is given by this function of v in terms of t. So for the first part, we have to find the values of t when the velocity of P is 100 meters. So this is very straightforward. So we just have to substitute v equals to 100 and solve for t. So we get 15 minus 2 squared equals to 100. Now we can take the square root of both sides. So we will get 15 minus 2t is equal to 10, or 15 minus 2t is equals to minus 10. All right, and now we're going to isolate our t. So 10 minus 15, you'll get minus 5. and then t will just be equals to 5 over 2. So this is our first answer, and then for this, we're going to move the 2t to the other side, so we get 2t and add 10 to both sides, so we get 25, and here you get t equals to 25 over 2. Okay, so these are our values of t and our final answers, 5 over 2 and 25 over 2. Let's head on to the next part. Okay, so for the second part, we're supposed to show that there's a particular value of t for which the velocity and the acceleration of the particle are both 0. All right, so to do this, we first have to know the equation for acceleration in terms of t. And to do that, we're going to take our equation for velocity in terms of t. Okay, so like this, and we're going to have to differentiate it because acceleration is dv dt. So let's do that. So for this, you're going to have to use a chain rule. So first you bring down the power, and then you minus 1 from the original power. And then you multiply by the derivative of the inner function. So that in our case, that's 15 minus 2t. So that's just minus 2. Okay. And then you get minus 4 times 15 minus 2t. Yeah, so this is the acceleration. We're going to solve for t when we make acceleration equals to 0. So let's equate it to 0. We'll get 15 minus 2t equals to 0. And then this 2t equals to minus 15. You'll get t equals to 15 over 2. Okay. And now we're gonna have to verify. So we're gonna sub t over 15 over 2. Okay, we'll let this be equation 1 and 2, 1. So v would just be equals to 15 minus 2 times 15 over 2 squared. So the 2's cancel out, so just 15 minus 15, whole thing squared, that's just 0 squared, which eventually gives us 0. Okay, and then hence, we can say that so we can say that for t equals to 15 over 2 seconds, both v and a are 0 shown. So this is our final answer for this second part. Okay. Let's head on to the third part. Okay, so for this question, we're told to find the displacement of p from O at the time that the velocity and acceleration of the particle are both 0. Okay, so for this we have to use the answer to the previous part, and we also have to know the formula for displacement in terms of t. So to find that, we're gonna have to integrate our formula for v. So s would just be the integral of 15 minus 2t squared. Yeah. Sorry, dt. So to integrate this, we're going to first add 1 to the power, so 3, and then divide by this new power 3, and again multiply, divide by the derivative of the inner function. So in that case, that's just minus 2. Don't forget your plus c. And this would give you minus 15 minus 2t cubed over 6 plus c. All right. And now let's okay, let me see. To find C, we're going to substitute S equals 0 and T equals to 0 because that's what they told us in the question. So this is going to be 15 minus 2 times 0, whole thing cubed over 6 plus C equals to 0. And then you'll get minus 15 minus 2, 0 cubed over 6. You will get C equals to 1125 over 2. So this is our constant of integration. So now we can finally have our formula for S. Okay, and now we're going to sub T equals to 15 over 2. So this would just be 1125 over 2 minus 15 minus 2 times 15 over 2 cubed over 6. So this would just give you 1125 over 2 meters. So this is our final answer for this final part. So this is the displacement of P from O. Let's head on to the final question. So for this final part, we are told that two particles A and B of masses 6.5 kg and m kg respectively are connected by a light inextensible string that passes over a smooth pulley. The pulley is fixed at the top of a rough slope. So that means this slope, whatever's on it, friction will be acting, which is at an angle of alpha to the horizontal ground, where tangent alpha is 5 over 12. So let's draw our triangle. So 5 is here, 12 is here. So use your Pythagoras theorem. You will get 13 as the hypotenuse. A is on the rough slope and B hangs below the pulley. Yeah, so we can see that. Okay, the coefficient of friction between the slope and A is 0.4. Okay, so for this part, we're told that given that the system is in equilibrium, find the set of possible values of M. All right, so for this, we are going to take this whole system as a whole and not split it up into two. So we're going to have to disregard the tension that's acting. So first of all, we have the weight in here. Okay, so the weight is just mg. And then we also have the weight acting on A. So that's just 6.5 G. All right, what else? Oh, okay, never mind. And then we also have the normal contact force. Okay. And then since this is going up, okay. So since this is going up, all right. Okay, let's just say that friction is acting here. Okay. All right. Now we can find our F. So F equals to mu n. So that's just 0.4 n. Okay. And then for alpha, it's going to be 6.5 G. This is alpha, so that's just cosine alpha. And then horizontal component would be acting here, which is 6.5 G sine alpha. Okay, now we're going to take the horizontal forces that's acting in the parallel to the string. Okay, we're going to take yeah. So since F and mg are acting in the same direction, we add them up. And we're going to equate that to 6.5 G sine alpha. So F is just 0.4 N and is 6.5 G cosine alpha. And this is mg. This is going to be 6.5 G sine alpha. Okay, and then 0.4 times 6.5 G. That G is 10, so that's just 26. Cosine alpha is 12 over 13 plus mg. That's equals to 65 sine alpha. Sine alpha is 5 over 13. Okay. Hmm. Okay. So this would just be 24 plus mg equals to 65 divided by 13 times 5. That's 25. And so mg is just equals to 1. So m is just 1 over g. That would give us 0.1 kg. So this is the first value of m. Now we're going to take the second value. So the second value assumes that friction will be acting in the opposite direction. So in this direction. So now we just have mg equals to F plus 6.5 G, 6.5 G sine alpha. So mg equals to 0.4 n, so n is 6.5 G cosine alpha plus 6.5 G sine alpha. So let's cancel out the G, you'll get m equals to 0.4 times 6.5. That's equals to 2.6. And then cosine alpha is 12 over 13. And then 6.5 times sine alpha, that's 5 over 13. M would just be equals to 2.6 times 12 over 13 plus 6.5 times 5 over 13. That's equals to 4.9 kg. So this is our second answer for M. So two answers is 0.1 kg and 4.9 kg. So these are our final answers for the first part. Let's head on to the next part. Okay, so for the final part, we're told that instead, m is equals to 12 and the particles are released from rest with the string taut. So we have to use an energy method to find the speed of the particles when each particle has moved 0.6 meters. Uh, so you may assume that this occurs before A reaches the pulley or B reaches the ground. Okay, so let's clean up all this. Okay, so basically we're assuming that, wait, did they? Oh, okay, so we're assuming that they're moving upwards. So A is moving upwards and B is moving downwards. So let's find the initial energy in here. So initially, B has GPE, okay, of 0.6 meters. Okay, and then A is still there. All right. Yep. Yeah. Okay. 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 Yeah. Okay. So B has GPE. So initially, GPE is equals to mgh, and M is 12, G is 10, and H is 0.6. Oh my, 0.6. So this is going to be 72 joules. So this was the GPE initially. There was no other energy. Okay, and then after that, the GP is converted to like kinetic energy. So since both of them are connected, we could assume they're both moving with the same speed. So finally, we have KE equals to half mv squared plus half m, okay, m1 v squared and m2 v squared. And m1 is just the mkg, so half m v squared plus half m2. M2 is 6.5, sorry, 6.5 v squared. So this is 6 plus half times 6.5. You will get 37 over 4 v squared. So this is the KE after they're released. Okay, and then, oh, and then A has also moved up, so we have to calculate the GPE. For the height, it would be the vertical height, so that's just 0.6 sine alpha. So, okay, GPE would just be mgh, so M is 6.5, G is 10, and H is 0.6 sine alpha. So you would get 39 times sine alpha. So sine alpha is 5 over 13. Yep. So that gives you 15 joules. Okay. All right. And now for the GPE, um, okay, so what else we have? Okay, so we have GPE. Obviously, there is work done against the frictional force when A moves up. Okay. So for that, still gonna be the same. So work done against friction. That would just be FD. So F is just mu N. Okay, mu N. Okay, that's oh, that's just 24. Yeah, it's just 24. So 24 times D. So D is just 0.6. Okay. Okay, so 24 times 0.6, you will get 14.4 joules. And now we can equate all this. So we add up all the final energies. So it's 37 over 4 V squared plus 15 plus 14.4 equals to 72 joules. And this is 37 over 4 V squared equals to 72 minus 15 minus 14.4. You will get 213 over 5. And V squared, just divide both sides by 37 over 4. You will get 852 over 185. And then take the square root of both sides. You'll get square root of 852 over 185. That's equal to 2.14 meters per second to 3SF. Yeah, so this is our final answer for this final part, as well as the entire question. And we've also come to the end of this paper. So I hope you found this video helpful. And if you did, please make sure to like and subscribe to this channel and stay tuned for more past paper solving videos of A-level maths and further maths. If you have any questions or doubts or any future video ideas, please feel free to leave them down in the comments below, and I'll see you again next time. Okay, thank you.